beautiful people, and welcome. In today's video, we're going to be talking about how to write an equation for a parabola. Now, some of these will be a given graph, and then you have to write the equation. But sometimes what they're going to do is they're going to just provide you information in text, and then you're going to translate that text into a form of equation. Disclaimer time, I am human, so if I make a mistake, that is okay, that is expected of humans, so let me know where the mistake occurs, and then that way we both can learn from my mistakes if that actually happens. All right, let's get started. If you are coming off of the previous video of graphing parabolas, in there are two equations that we were talking about that gave us all of the information that we needed to graph. Now, because we're writing the equation of a parabola, we're going to be working backwards. So it's still super duper important to identify all of that information. So we have two equations. First one is y minus k squared is equal to 4p x minus h. The secondary equation is x minus h squared is equal to 4p y minus k. Now, both of these equations are for parabolas. One of them is opening to the left or to the right. The other one's opening up or down. So which one's which? Again, recall from that video, the way I like to think about it is I like to look at my P, and P is going to tell you a lot. Whatever P is attached to, look at that axis, and that's going to tell you the direction your parabola is going to go. For example, P is next to x. X is a horizontal axis, so your parabola is going to open to the left or to the right. So if P is greater than 0, we're going to open to the right. If P is less than 0, we're going to open to the left. Now, again, important information. We want our vertex, which is h comma k. We want our focus, which is h plus p comma k. And then we have our directrix, which is x equal to h minus p. Let's do exactly the same thing for the other equation. Again, what is p attached to? P is attached to y. Y is a vertical axis, so our parabola is going to go up or down. So if P is greater than 0, we are going to go up. If P is less than 0, we're going to go down. And what I mean by going up or down is the parabola is going to open upward or open downward. Open to the right or open to the left. Okay, so vertex is h comma k. Our focus is h comma k plus p, and our directrix is y equals k minus p. Now, I wanted to take a few moments to make sure I rewrite this information from the previous video because it is super duper helpful. You will need this information. All right, let's go ahead and jump into some examples. We're going to start off with example number 1. Let me see if I pre-printed these out. Again, all of these are going to be write the equation for the parabola. So again, sometimes they're going to give you a graph and then ask you to write, but you're also going to need some information, so they have to give you some information. So for example number 1, they're going to give you a focus of 0, 5. The directrix is y equals 5. And they also tell you, for example number 1, that your vertex is at the origin. So my number 1 recommendation when you're writing these equations is draw them out. I am a visual person, so for me, drawing them out helps a lot. So I'm going to do that. Focus is 0, 5, so 0, 5. Here's, what is this, 2, 4, 5. Here's my focus. Directrix is at y equals 5. Here's negative 4. This should be negative. Here's my directrix. I know that my directrix always has to be outside of my parabola and my focus has to be inside of my parabola. So if, for instance, this was not sketched out, there would be only one option for our parabola to have the focus inside, but then have its directrix on the outside. There is no other way we can draw this. Okay, since the vertex is at the origin is 0, 0. And so now I'm looking back here at our equation. Which one's which? Which one do I use since we have two equations? Look at how your parabola is open. It is open upward. To go up, you are on the y-axis, so P is attached to y. So we are dealing with this equation. And whatever P is attached to, that's the thing that's not squared. We know what we're dealing with the origin. Let me see if I can find a pencil, which I had here. There it is. Okay. So the origin is our vertex, which is h comma k. So once we have the correct formula that we need for the equation, we just start plugging stuff in. So we know h is 0, k is 0. X we're keeping, 4 we're keeping, P we're going to need, and then Y we're keeping. Oops. That's ugly. Let me erase better. Okay, so how do we find P? There are also two pieces of information that they provided to us, and that is they provided the focus and the directrix. So looking at, again, I have my cheat sheet in front of me. Your focus is going to be h comma k plus p, and your directrix is going to be y equals k minus p. So we know what k is. K is 0. So p is going to be what? So we need to find out what P is. So you can say that you can do it two different ways. You can set this equal to that. I'm going to choose to go with the focus. And so we are setting this equal to each other. So H is equal to 0. So K plus P is equal to 5. So K plus P is equal to 5. And we're getting that from our focus right here. So we're going to solve. K is 0. So P is equal to 5. So let's finish off our equations by simplifying. We have x squared is equal to 4 times P, which is 5, times y. And then simplify once again. So I have x squared is equal to 20y. Now, sometimes what you're going to see, the standard form of the equation without the x squared being equal. So what I mean by that is, you know how regular equations typically start with y equals? So sometimes, depending on your teacher, depending on the class, sometimes they will say this is not the standard form of the equation. We want it to be y equals. In my class, I am okay if you leave it here. We are calling that standard. But I want to show you how other teachers might expect you to write it. So we're going to say y is equal to, we want to get y by itself. So how do we get y by itself? We're going to divide by 20. And you can either write it as 1 over 20 times x squared, or you can say x squared divided by 20. But this is another way that you can write the equation. So here's your example on writing an equation giving a vertex at the origin, a focus, and a directrix. Let's move on to our second example. Let's see what they're going to give us. and they're going to give us a focus and a directrix. So focus is 0, -4. Directrix is at y equals 4. And again, your vertex is at your origin. Very similar to example number 1. Since we have our vertex at our origin, our vertex is 0, 0. That means this is h, k. But here's the difference. Here they gave us a sketch. Here they did not give us a sketch. So which equation do we use? How do we know which way it's going to open? Sketch your focus and sketch your directrix, okay? Directrix has to be outside of your curve, of your parabola, and then your focus has to be inside of your parabola. So 0, -4 is your focus. So this dot right there has to be inside of your parabola. Your directrix is y equals 4. So here's your directrix. And then your vertex is at 0. So looking at our 3 pieces of information, you know for sure that it's going to be a downward opening parabola. If we do anything, if we go sideways, left and right, your focus is not inside your parabola. If we have it facing upward, going upward, your focus is not inside your parabola. So the only way to enclose your parabola, the only way to have your focus be inside the parabola is if we go downwards. All right, so let's go ahead and sketch. I did sketch already. Excuse me for that. Let's write our equation. Since we're going downward, we're going down. Down is that's a vertical change, going down. So that means we're having our equation or our P next to our Y. Because vertical change is the change of the Y. Therefore, P is going to be next to Y. Therefore, X is going to be the one that's squared. Again, origin. So we're going to rewrite this. I'm going to not put 0 in here, but we know that h is equal to 0 and k is equal to 0 from our origin. But I'm going to try to simplify it a little bit. And again, trying to find our p. Recall that our focus is h, k plus p for an upward or downward parabola. Your focus changes if it's left and right. So now I'm going to set k plus p equal to -4. K is 0, so p is equal to -4. So my equation is 4 times -4 y. So then I have x squared is equal to -16y. Or, again, depending on who your teacher is, they might have you divide. So I have y is equal to -1/16 times x squared. All right, let's move on to number 3. For example number 3, we're going to be given the focus and directrix. Let me see here real quick. I'm going to see if we can do a different example that's not on having the vertex. I'm going to leave this one. We're going to come back to that one. I want to focus on this one right now. So this is where you have your vertex not on the origin. So you have your focus at -1, 4. You have your directrix at y equals 6. So as of right now, they do not tell you what your vertex is. These are the only two pieces of information that they give you. And with your focus and your directrix, it's more than enough. Again, step number 1 is always to sketch what you have. So your focus is -1 and 4. -1, 4, here's your focus. Your directrix is at y equals 6. So here's a thinking bubble situation. You need to recall that your vertex is the midpoint between the focus and the directrix. So what is the midpoint between 6 and 4? That midpoint is 5. So your vertex is here. What is the only option of you to graph? Excuse me for that hesitation. So we have one option to have our focus inside our parabola, and that's if our parabola is facing downward. To sketch the parabola to have it exact, you can go back to the graphing video on finding out the lotus rectum and finding the endpoints of that. You can do that there once you have the equation to sketch a graph. So sometimes they're going to have you sketch the graph after you have written the equation. But now we know our vertex. So vertex is what? -1, 5. It's facing downward. Down is a vertical change. So the P is next to Y. So we have x minus h squared is equal to 4p times y minus k. Now, since our directrix, since our vertex, I will get it right eventually. Since our vertex is not 0, 0, our h and k values are now different. Now remember, whatever you see inside the bubble, it's going to be opposite that when you actually write it. So I have x plus 1, because it's h comma k, squared, 4 times p times y. I see a positive 5, so I'm going to be writing a -5. Now we still need to find what our p value is. Recall that our focus is h comma k plus p. So k plus p is equal to 4. K is equal to 5. So I'm going to subtract. P is equal to -1. So I have x plus 1 squared is equal to 4 times -1 times y minus 5. Simplify that one last time. And you have your equation. All right, so let's move on here. We have our focus, we have our vertex. So notice on these examples, they do not give us the directrix, and that's okay. Something about this example I want to point out is it should make sense. For example, it is facing downward, so we should have a negative p value, which we do. So if something doesn't match, if your sketch doesn't match your p value, then make sure that that's an alert you have in your head. So vertex, focus, again, I don't know how this looks like, so I have to sketch it out. And it doesn't have to be anything fancy. Don't even label stuff. So -7, 9. So -7 is here, 9 is here-ish. That's your vertex. Then we have -7, 35 over 4. So round that out. You can use your calculator if you have a calculator to do a decimal, but we're just trying to get a rough estimate of it. So we have 35 divided by 4, that's about 8.75. So your focus, here's your vertex, here's your focus. If this is 9, this is 8, so 8.75 is about here-ish. That's your focus. So with your vertex and your focus, you already know that your vertex will be on the parabola, but your focus has to be inside. So the only option I have is to go downward like this. So then we know vertex is h comma k. And then since it's going downward, down is a vertical change. Vertical is the y-axis. Therefore, p is attached to y. So we have x minus h squared is equal to 4p times y minus k. Again, vertex, whatever you see, you're going to write the opposite inside the bubbles. And then solve for p. We know our focus. Our focus is h comma k plus p. So k plus p is equal to 35/4. K, what was k equal to? K was equal to 9. So I'm going to subtract 9 both sides. P is equal to 35/4 minus, I'm going to write that as a fraction. Yeah, you don't want to use decimals here. Don't use decimals. You'll notice that they're giving you fractions. You do not want to use decimals. Only use decimals when approximating where your values are, or you convert that to a mixed number. So it's 8 and something else. So 9 times 4 is 36. So P is equal to -1/4. So our final equation here is x plus 7 squared. Oh, you can't see that. Let me scooch that up. X plus 7 squared is equal to 4 times -1/4 times y minus 9. Simplify that. X plus 7 squared is equal to, 4's cross out, I have negative. You can do a -1 or you can just write negative out in front. Up to you. Here's your equation. Let's do one more. Hopefully, I just realized all of our examples are using the equation for the up and down parabola. So maybe this one will be left and right. If not, then I will find you an example. We have to do at least one that is the other equation. All right, let's do this really quickly. I'm actually going to take a moment. You won't notice this because I'm going to edit this together, but I'm going to pause this video just for a few moments and then get back to you with the horizontal parabola with opening to the left and to the right examples. All right, beautiful people. That was a very short break for you guys. But let's go ahead and do this example. Now, this example will be a left or a right parabola, opening leftward or rightward. So let's get started. But it's going to be exactly the same thing, just the equation's going to be different. So again, looking at the given information, there's no way for you to tell if it's going to open leftward, rightward. We're going to sketch it out. I have 6 and -5, so here's +6, here's -5. And then I have 25/4. So 25 divided by 4, that's about 6 and a little bit, so 6 1/4, 6 1/4. So if this is -5, I have, and this is 6, 6 1/4 is about here. Again, we're just guesstimating where these values are. We just need to see if the vertex and the focus, where their location is. So this one was our vertex. Our focus is 6 1/4 at -5. So looking at it, our focus has to be inside of the parabola. So we're going to be opening to the right. That means P has to be positive. We already know that because it is opening to the right. So be careful. This is where, since it is opening to the right, Similarly, if it would be opening to the left, our equation now changes. It is opening with, let me back up. It's opening to the right. A right is a horizontal change. Horizontal is the x-axis, so P is attached to x. So we have 4P times x minus, remember, h is always attached to x. So we have 4P times x minus h, and that means y minus k is the one that's being squared. So that's the first thing that changes. The second thing that changes is your focus. Your focus is now h, it's now h plus p, comma, k. So vertex still is h, comma, k. That doesn't change. So y, what is k? K is negative 5, so we're going to write positive 5 squared is equal to 4 times p times x. H is 6, so we're going to write negative 6 here. Our vertex is, our focus is 25/4 equal to h plus p. Again, how did I get that? Here, h plus p is 25/4. For a moment, you guys could see my pencil, and now you can't see my pencil, so that's weird. Okay. So now we have to solve for p. H is 6, so we have 25/4 is equal to 6 plus p. Going to subtract 6. 6 is 25/4 minus 6 is equal to p. Now we're going to convert this to common denominator. Make sure you're dealing with fractions. Do not use that calculator and convert this to a decimal. Don't do it. So now we have 1/4 positive is equal to p. Coming back up here, we have y plus 5 squared is equal to 4 times positive 1/4 times x minus 6. So my equation is y plus 5 squared is equal to x minus 6 since these cross out. All right, beautiful people, this is going to be one of our last examples for this video. Now in this example, I will be introducing one new formula for you, or one new equation for a parabola. Now this equation, you can derive this equation from the two previous equations, but I'm going to simply give that to you so that way we can wrap up this video. So one of the forms of the parabolas that we have is called the vertex form. And that equation is y equals a, parenthesis, x minus h squared plus k, where h, k is your vertex. This vertex form is really useful when you're trying to write an equation of a parabola when you have only the vertex and some other piece of information that's not the directrix or the focus. So how do you apply this? Let's look at our example. We have the vertex at 8, negative 1, and we have the y-intercept at negative 17. If you are in my class, you should already know that a y-intercept means it is a point on the y-axis. And I cannot stress enough the fact that it is a point. It's just a point. So that means there is a point on 0, negative 17. And why I'm stressing the fact that it is a point is because, well, what do we know about points? We know that the first number represents an x and the second number represents a y. So if we look back at our vertex form, I notice I have an x, I notice I have a y. What do we know about our vertex? Vertex is h, k. Looking back at our vertex form, I have an h, I have a k. So when we use the vertex form when writing this type of equation, you are going to be finding out what your a value is. So y equals a x minus h squared plus k. So again, our y is negative 17. I keep writing commas. I don't know why I keep writing commas. Is equal to a, we don't know what a is. X, we said is 0. H is 8, so I'm going to write whatever is opposite, so negative 8. K is outside the bubble, so I'm going to write it as is. Only change the sign of your numbers if it's inside the bubble. Okay, so let's solve for A. 8 times 8 is 64, even when it's negative. Almost left out my A. Don't subtract 64 and 1. A and 64 in a bubble. So I'm going to rewrite it so that way it looks prettier. I have 64a minus 1. I'm going to add 1 to both sides. So I have 18 is equal to 64a. So I have 18 divided by 64 is equal to a. And don't you dare convert that to a decimal. No decimals. You can, however, simplify. So what goes into 18 that also goes into 64? I don't know about big numbers, but I know 2 works. So it is 9, and 64 divided by 2, it is 32. That kind of looks like an 8, but that is a 9. And does anything go into 32 and 9? Well, the factors of 9 are 3. So does 3 go into 32? It does not, so we're going to leave it. And 9 does not go into 32. So A is 9/32. That sounds silly, 32. And we're going to finish our equation by saying y equals 9/32 times x minus h. Ooh, we know what h is. We know what h is. H was, what was it? 8 squared minus 1. And again, depending on your teacher and how they want you to write your equations, if we wanted to go back to standard equations, then we would say y minus 1 is equal to 9/32 times x minus 8 squared. I'm going to multiply both sides by the reciprocal. So I have 32/9 times y minus 1 is equal to 8 minus 8 squared. Now, if you go back to the beginning of the video, you're going to notice that typically the squares are on the left-hand side. It doesn't matter. It's an equation. Both sides are equal. So you can have the squared on the right-hand side. You can have the squared on the left-hand side. It just matters what it is attached to. Okay. I want to take this moment to do a personal service announcement on parabolas and the equations. What you're going to find is a lot of different types of formulas out there. So if you're watching my video or any other video, or you're looking at textbooks, there is a discrepancy on what is called what. So sometimes you're going to watch videos that call this the standard form. Sometimes you're going to watch videos that call something else the standard form. This the standard form. This is maybe the generic form. So there's very different ways to name these type of equations. So please do not let that confuse you when you are studying for any sort of assessment or completing your assignments. Make sure that if you are watching other videos that you remember the way that you are being taught in class and what terminology you are using in your class. Because that terminology those keywords that you're using in your class will show up on your homework and will show up on your assessment. If you are watching other videos, that means that they may call something by a different name, and you might get that question wrong on an assignment or a assessment. So that's my 2 cents. Personal service announcement. We are calling these the standard form of a parabola equation. We're going to call this one the vertex form. And then in the previous video, we also called the general form, which was the expanded, when you multiply everything out. All right, beautiful people, that wraps up this video. I hope you enjoyed it, and I hope you learned a lot. Like, share, subscribe. You know the drill. I appreciate every single one of you for watching my videos. Thank you so much, and take care.